Let's think about how to compute the value of this limit. First of all, we can try plugging in x equals 5 and see what happens. In the numerator, this gives us 1/5 minus 1/5, or 0. And in the denominator, we get 5 minus 5, which is also 0. Therefore, this limit is of type 0 over 0, so it's an indeterminate form. As we've seen in other examples, this means that we need to rearrange it before we can compute the value of the limit. Let's begin by rearranging the fraction so it doesn't look quite so complicated. Remember that dividing by x minus 5 is the same as multiplying by its reciprocal, 1 over x minus 5. Therefore, we can rewrite this expression in the following way, and so it's no longer fractions within fractions. Let's now focus on the expression in parentheses, which is the difference of two fractions. In order to rewrite this expression, we need to find a common denominator. But notice that the two denominators, x and 5, have no common factors, and so our common denominator is going to be 5x. Therefore, we need to rewrite each of these fractions as a fraction whose denominator is 5x. For the first fraction, 1 over x, we already have x in the denominator, so if we multiply this expression by 5 over 5, we'll create a fraction whose denominator is now 5x, but we won't change anything because 5 over 5 is just equal to 1. Similarly, for the second fraction, we already have a 5 in the denominator, so we need to multiply by x over x in order to make the denominator equal to 5x. Rewriting this expression, we see that we have 5 over 5x minus x over 5x. Since these two fractions now have the same denominator, we can write this difference as a single fraction, where the numerator is now 5 minus x, the combination of the two numerators in the previous line. We can now take this expression and plug it back into our limit expression. Here's what the new limit expression looks like. Before we move on, let's combine those two fractions into a single fraction. Now notice that we can take the numerator and rewrite it by factoring out a minus 1. This is because 5 minus x is the same as negative 1 times x minus 5. By doing this, we see that we now have a common factor of x minus 5 in the numerator and the denominator, which we can now cancel. This leaves us with negative 1 over 5x, which is now well defined at x equals 5. So we can plug in x equals 5 to see that we have negative 1 over 5 times 5, or negative 1 over 25, which is our final answer.